Welcome students in the organic chemistry lectures. In this video we are going to study about these three concepts, that is racemic mixture, racemization and mesoform. In last video we have seen about the diastereomer, that is one of the optical isomer. Now few concepts are there which we have not taken in the optical isomerism part, but they are very important while studying the stereochemistry. So we have to study them. The first concept which we have to understand is racemic mixture. So one by one we will see this concept. Okay. So the first concept is what is racemic mixture, that we will see. Now before studying this racemic mixture, we have to recap about enantiomers. So we know that enantiomers are non-superimposable mirror images of each other, and they are denoted by D and L form. D and L form. So D for dextrorotatory, this we have seen, okay, and L for levorotatory. Now what is this dextrorotatory and what is this levorotatory? I have explained at the time of enantiomers, though I will recap this part. So dextrorotatory means enantiomer which rotate the plane of polarized light to the right hand side, and levorotatory means an enantiomer which rotates the plane of polarized light to the left hand side. Okay. So if a mixture contain, so this is very important, remember, if a mixture contain equal amount of D and L form, then this mixture is called as this mixture is called as a racemic mixture. So this is very important, remember, a racemic mixture. Okay, so I will once again explain. We know that a D form means dextrorotatory, that means this form rotates the optical plane polarized light to right side, and levorotatory means it rotates the plane polarized light to left side. But if a mixture contains equal amount of D and L form, then this mixture is called as a racemic mixture. So what is racemic mixture? A mixture which contains equal amount of D and L form. So this is very important, remember. Another important thing is that a racemic mixture is optically inactive, remember. A racemic mixture is optically inactive. Okay. So this is a very important point, that racemic mixture is optically inactive, and it is represented by DL or plus minus. So in this way we can represent the racemic mixture. Okay, so I think it is very simple to understand the racemic mixture. So it is the first point, that is racemic mixture. Now we will see second point, that is what is racemization. Okay, that we will see. Racemization. Okay, so I will write what is racemization. It is a process of separating a racemic mixture. It is the process of separating the racemic mixture into its components. Okay, so it is very simple. What is racemization? It is the process of separating the racemic mixture into its components. And what are that component? That components are D and L form. Now most of the physical properties of the enantiomers are same, we know that. Okay, like boiling point, melting point. So it is very difficult to separate the D and L form. So how they are separated? that we have to consider. Therefore, the enantiomers cannot be separated by physical methods. Remember, enantiomers can't be separated by physical methods, physical methods, because they have same physical properties. So it is very difficult to separate them by using physical methods like fractional distillation or fractional crystallization. Okay, so they cannot be separated even by chromatography, because both the enantiomers are equally strongly held at the adsorbent. So chromatography technique is also not used. Therefore they are separated by special methods like mechanical separation, preferential crystallization, biochemical and chemical methods. So remember that this racemization is done by using mechanical separation, mechanical separation, again by preferential crystallization. Remember this, preferential crystallization, and by using biochemical and chemical methods, biochemical and chemical method. So I will once again summarize. Remember, what is racemization? Racemization is the process of separating the racemic mixture into its components. That components are nothing but D and L form. Now it is very difficult to separate D and L form by using physical methods like boiling point, melting point, because they have same physical and melting point. Also it is very difficult to separate the uh, enantiomers by using fractional crystallization, fractional distillation, and even by chromatography technique. Okay, but they can be separated by using these techniques: mechanical separation, preferential crystallization, biochemical and chemical methods. Okay, so this is about second point, that is racemization. Now in third point, that is mesoform, we have to see now. So we'll see about mesoform. Okay, now to understand mesoform, I will take one example so that you will easily understood what is mesoform. So consider the Fisher projection of this compound. I will draw here the structure of COOH, COOH, it is HOH, OH, H. Okay, if we place the mirror, we'll get this form OH, H, H, OH. Here is a COOH. Now we know that these two structures are enantiomers of each other, right? We have seen this because these are non-superimposable mirror images of each other. But if we draw the structure in this way, now you see here, if we draw the structure in this way, suppose here is OH, here is also OH, COOH, COOH, H and H. Or if we draw the structure in this way, OH, OH, COOH, COOH, H and H. Okay. Now you see here, if we cut this molecule in this way, we get two equal parts. Here also if we cut this molecule, we get two equal parts. That means there is a plane of symmetry in this molecule. Plane of symmetry. Okay. So if the molecule has plane of symmetry, then a molecule can be divided into two parts, and therefore this compound is optically inactive because it has plane of symmetry. Such forms are called as mesoform. Remember, mesoform. So what is mesoform? Structure 3 and 4. Suppose if we give number 1, 2, 3 and 4, so we can say the structure 3 and 4 are optically inactive. Why they are optically inactive? Because they have plane of symmetry. So such structures are called as mesoform. So remember this concept. Okay, so it contains plane of symmetry due to internal compensation that is the rotation produced by upper half of molecule is nullified by the rotation produced by lower half of the molecule. Therefore, molecule is optically inactive, remember. So this is all about the mesoform. So in this video we have seen the three different concepts, that is what is racemic mixture, this thing we have seen. Then we have seen racemization process, and third point we have seen is the what is meant by mesoform. Okay, so these three points are very important as per the stereochemistry is concerned. So in this video we will stop here now, and we'll meet in the next video with a new concept of stereochemistry. So have a nice day. We'll stop here. Thank you.